Welcome to this lecture on course Machine Learning using Python Programming. In the previous lecture, we have seen polynomial regression. So, polynomial regression is used when the relationship between response variable and predictors are not linear, and we have seen in detail how we create polynomial regression model for the given data set. So, in today's lecture we will see decision tree and KNN, these two more machine learning models for regression problem. So, let us start from decision tree. So, decision tree we can use for classification as well as regression. In today's lecture we will see how decision tree can be used for regression, and then later when we will start classification, then we will see how decision tree can be used for classification problems. Decision tree can be used for classification as well as regression. So, when we use decision tree for classification, the tree that is learned is called as classification tree, and if it is decision tree is used for regression problem, then the tree that is learned is called as a regression tree. In case of decision tree, we can say your model is the tree that will be created. So, we need to create a model, we need to create a tree, and using this tree we will predict the value of the response variable, and the value of the response variable will be predicted based on the decision rules, and these decision rules are embedded in the decision tree. So, these decision rules, how we will learn these decision rules that are embedded in the decision tree. So, these decision rules will definitely be learned from the data set or different feature values in the data set. So, we can say in case of decision tree, your model is learned from the data set, and in that case your model is nothing but the decision tree, and there are different decision rules that are embedded in the decision tree, and when we will predict the value of the response variable, we will use those decision rules. So, when you will learn the model, so your model will be complex when the tree is deep. So, if the learned tree is deep, in that case your model is complex and there may be chances of overfitting. So, generally regression trees are more complex than classification trees, but in any of these case, if your tree is complex, it means your model is complex and there may be chances of overfitting. So, in that case we will see we use pruning of the decision tree. So, that we will see later how we can use pruning to avoid overfitting. So, now decision tree regression model generally we use when our data set is a high dimensional data set or number of features are very large. Otherwise, if your data set is having single feature or very less features, then generally we can use other regression models like simple linear regression model or multiple linear regression model. But if your data set is high dimensional data set, then it is useful to use decision tree. So, now we will see what are pros and cons of decision tree model. So, first of all, the results of decision tree would be very easy to interpret, because prediction results that we get are based on the decision rules. So, since we have decision rules, so by seeing those decision rules we can interpret why we are getting these prediction results, and that is why we say in case of decision tree interpreting results becomes easy. So, this is the advantage of decision tree. Further, there is no need for feature scaling, as in the previous starting few lectures we have seen when we do the data pre-processing task. In that task, one of the task is feature scaling. So, feature scaling we have seen is required for those machine learning models that are based on the distance metric. So, in case of decision tree, that is not based on the distance metric. So, we do not need feature scaling. And then this decision tree works for linear as well as non-linear both cases. So, if there is a non-linear relationship between response variable and independent variables or predictors, or there is a linear relationship between response variable and predictors, in both of these two cases we can use decision tree. So, if your data set is small or number of features are very less, in that case there is a chance of overfitting in your case, and that is why we should use decision tree if your data set is very large or the number of features are large. So, let us see how this decision tree can be used for regression purpose. So, first of all, we are taking one example where there are two features x1 and x2. X1, x2 are the independent variables and y is the dependent variable. So, here we are talking about a data set where two independent variables or two predictors are there and one response variable is there. So, we can have the scatter plot of the data set. So, this is the scatter plot where x1 is shown on the x direction and x2 we have taken on the y direction. So, these stars are representing the values of y corresponding to x1 and x2. So, how decision tree algorithm works? In case of decision tree, the whole data set is divided in different parts. So, here we are not going in detail to see how we divide the data set, what is the criteria for dividing the data set. Here we are simply seeing one example to understand what is the decision tree and how it works for the regression case. So, we will suppose here we are dividing the data set based on x1 is greater than equal to 20 or x1 less than 20. So, you see here we divided this whole data set in two parts. So, this is the first part and this is the second part. Then again we will divide one of these subparts. So, suppose this subpart is again divided in two parts by having the rule x2 is less than equal to 170 or x2 is greater than 170. So, now the original data set is divided in three parts. So, after that we will suppose we are again dividing this part in two parts. So, we are using the rule x1 is less than 38 or x1 is greater than equal to 38. So, this part is representing x1 is greater than equal to 38 and this is x1 is less than 38. So, suppose we have again divided this portion. So, it is divided based on the rule that x2 is less than 150 and x2 is greater than equal to 150. So, you can see here the whole data set is now divided in these parts, these 5 parts, and then we will see how we will see the actual algorithm. Let us see how the decision tree is created when we split the data set in different parts. So, first of all we divided the data set using the rule x1 is less than 20 or greater than equal to 20. So, if x1 is less than 20, so this is at the root, and then based on this condition either true or false, we are dividing this data set in two parts. So, if x1 is less than 20, this condition is true. So, it means now this here the node will represent, this node is representing this part and this node is representing this particular part. So, then we divided it further. So, this node is further divided in two parts based on the condition x2 is less than 170 or greater than 170. So, now one node is representing one of these two parts and another node is representing the other one. So, in this way the whole decision tree will be created, and we divided our data set in 5 parts. So, after when we are splitting this data set, so simultaneously this tree is formed. So, this is called as the decision trees, and we can see here these are the decision rules, because using these decision rules we are splitting the data set. So, this is the way decision tree works. Now, we will see how this decision tree can be used for regression purpose. So, suppose any new point, any new data point you are having. So, suppose that new data point is here. So, how we can predict the response variable value of that data point? Since that point is belonging to this group, so how we will find that it is belonging to this group? We will check whether x1 is for that new given instance. If x1 is less than 20, we can go here. If x1 is greater than equal to 20, we can go to this node, and further we will check the value of x2 for that new instance. Then again we will check if it is less than 170, then here, or greater than equal to 170, then here, and then this node will represent one of these subgroups. So, suppose this your new data set comes here. So, and this node is representing this data set. So, you will say that new instance, new data point for which we want to predict the value of response variable. So, that instance belongs to this part of the data set. So, how we can get the response variable of that data point? We will take average of the response variables of all the data points that are belonging to this group. So, in this way decision tree works for regression problem. So, you see here these are the suppose average value of the response variables of all the data points belonging to that group. So, we can now we put those values in the corresponding nodes, leaf nodes. So, if your data now we will decide for the given new instance, we will find whether it is belonging to this group or in which particular group, and suppose it is belonging to this group. So, its average response variable value is already written here. So, we will predict this value as a response variable value for that new instance. So, in this way decision tree algorithm work, or what is the algorithm? So, basically decision tree is finding the optimal splits of the data set into leaves. So, we have already seen the whole data set is splitted into different leaves. So, you can say leaves are now representing different subgroups of the data set. So, final leaves are called terminal leaves, and how and where to split data set, this we have not discussed in this today's lecture. We will discuss it when we will study decision tree in detail in case of classification. Then we will see how this split is done, or where to split our data set. So, after that, why we are splitting? Because after splitting we are getting more information about the response variable value for the given instance. So, after splitting y we are getting more information. If we will not split this suppose whole data set and any new instance is coming, how we can predict the value of y, value of target variable? We can take average of response variable of all these instances and then we can give this as a response variable value of the given new instance. But what we have done, we have divided this data set in different parts. After few lectures we will see that when we divide this data set, we divide in such a way that all the instances that are now in one group, one subgroup, these are similar instances, these are close to each other. In the same way these instances are close to each other. So, now if a new instance is that we are getting, suppose it is belonging to this group, it means these instances are more close to the new instance and that is why it is better to take average of response variable of only these instances and then give that as an output, that as an response variable value of the new instance, rather than taking average of response variable value of all the instances. So, in this way decision tree helps us in the regression problem. So, using regression tree we can find the response variable value, we can predict the response variable value. Now, another question is when your algorithm will stop, because we are splitting the data set in different subgroups. So, when we will stop splitting any node, any leaf node, so that leaf node is corresponding to one subgroup. So, when we will stop splitting that node or when we will stop splitting any node, so that we will need to decide. There may be different termination criteria for stopping the algorithm. So, one of the stopping criteria may be if they are in one particular leaf node, there is only 5% of the total data points, then we will not split again that particular leaf node. Or we can apply another criteria, if the leaf node that we are getting, we can find out any way to find the purity of that leaf node, and then based on that we can say if purity is less than some particular value, then we will split, otherwise we will stop. It will depend which particular stopping criteria we are using. The next algorithm for regression problem, so that is K nearest neighbor or KNN. So, KNN is very popular algorithm. Again this can be used for classification as well as regression. So, in today's lecture we will see how KNN can be used for regression problem. So, this KNN is instance based learning and it is called as lazy algorithm. So, let us first discuss what is difference between instance based learning and model based learning. When we solve any problem using machine learning models, so first of all we do the training and then testing is done. So, during the training, if model is learned, then it is called as model based machine learning or model based learning. If during the training no model is learned, then it is called as data based learning or instance based learning. So, for example, we have seen decision tree. So, decision tree is learned during the training process and then during the testing any new instance will come and then we will predict the value response variable value. So, that is done in the testing phase. So, in the training phase model was created or model was learned, while in case of K nearest neighbor, that model will not be created during training phase, and that is why we will see it is instance based learning. So, in K nearest neighbor we do not create any model. During the training phase only we store the data into memory, and during testing phase we do the whole process, and that is why it is also called as lazy algorithm. So, why it is called as instance based learning? Because no model is created during the training phase, during the testing phase everything is done, and that is why it is called as lazy algorithm. In all the machine learning algorithms where during the training phase we create model, so those are not called as lazy algorithm, because model is already ready, and during the testing phase we will use that model to predict the response variable value. So, again this KNN we use for non-linear, this is a non-linear model. So, we can use when the relationship is non-linear, but it is very compute intensive. We will see why it is very compute intensive, and that is why we need more computation power. And k nearest neighbor, so there is a we can say there is a parameter that is k, and that is nothing but number of neighbors. So, as the name suggests, k nearest neighbors. So, here we will take k nearest neighbors of the given instance for which we need to predict the value of response variable. So, we need to find out how many k values we will need to take. So, the default value is 5, but we can take any value of k. So, how this algorithm works? For any given new instance for which we need to find the response variable value, what we do, we will find from the data set what is the closest instance to this new instance, and what we can do, we can say the response variable value of the new instance is same as the response variable value of the closest instance. So, here we are talking about the case when k is 1. So, we are only finding one nearest neighbor. So, the instance that is the closest to the new instance and its response variable value we will use, and same value we will predict for the response variable value of the new instance also. So, means this is one nearest neighbor algorithm. One nearest neighbor algorithm will work on this way. Now, we will how we will find the nearest neighbor of the new instance. So, definitely we will need to use any distance metric that will find out the nearest neighbor of this new instance. So, we can use Euclidean distance or Manhattan distance or cosine or any other distance metric we can or similarity metric we can use to find out the nearest neighbor of the given instance. So, this is called as one nearest neighbor. We have already seen. So, during the training phase we will only save examples. During the prediction phase or during the testing phase we will get the test instance or the new instance, and we will find the training example that is closest to the test instance, and we will predict the value of this test instance as the response variable value of the training example, that is the closest to this test example. Now, what is the limitation of one nearest neighbor? Limitation is that suppose the nearest neighbor of this test instance is outlier. So, in that case your prediction will be wrong. So, it is always better if we will find out k nearest neighbor, and then we will take average of response variable value of all those k instances, and that we will predict as a response variable of the test instance, and that is why there is a k nearest neighbor. So, we will need to find some method to decide for the value of k, but after deciding that how the k nearest neighbor algorithm will work, we will need to find out k nearest neighbors means k instances in your data set that are closest to the test instance, and then we will take average of y1, y2 up to yk, where y1 is the response variable value of the first closest instance, y2 is the response variable value of the second closest instance, and so on. So, when we will take average of these, and that is the estimate of the response variable value of the test instance. So, in that case, if one outlier is there, but we are taking average of suppose 10 nearest neighbors. So, there are chances that we may get better prediction. So, now we can use many distance metric in this case, and we need to find out the value of k, and we have seen how we will prepare model in case of k nearest neighbor algorithm. We will need to first of choose the value of k, then we will take k nearest neighbor of the new data point, suppose according to Euclidean distance or any distance metric. Then we will find these k neighbors and will calculate average of response variables of these k nearest neighbors, and then we will assign new data point to this calculated average of y values. So, in this way KNN can be used for the regression purpose. So, in this lecture we have seen two algorithms, two machine learning models, first decision tree and second k nearest neighbor or KNN, and we have seen how these two algorithms can be used for regression purpose. Although we have not seen in detail how decision tree algorithm exactly works, or how we split is done in the decision tree, but the basic idea behind decision tree and KNN, we have seen how these can be used for the regression purpose. So, next in the next lecture we will see some other techniques of regression. I am stopping here. Thank you.